Happy, happy, happy. Happy, happy, happy.
Телекомпания Douglas Productions and Svetlana Productions. Movie Three-Phase Resonate Transformer Experiment. Sponsor of program Svetlana Konzen. Experiment of Douglas Konzen. Inventors of Free Energy Motors. Enjoy the video.
Okay, for the primary in this transverter experiment, I wound a coil here. It's 669 ohms, and it's 36 gauge wire, which is very thin, and I wound it up on this here, and afterwards you can take it apart and pull the sleeve out. And so this coil that I wound is 669 ohms, and the input is going to be 120 volts, 60 hertz. The inductance of this coil here is 3.25 henries, and there's that 36 gauge wire. Well, this coil here is going to be the secondary and what's going to be connected to the load. I don't know if it's going to work well or not, but I already have it on here, and it's 12 multifilar series 18 wires, 24 gauge. You can see I've hooked them all up. Series 18, and it's 9.5 ohms and 0.13 henries. Quite a difference in inductance between the primary and the secondary, and quite a difference in ohms. So this should draw about 0.175 amps at 120 volts at such a high impedance. So it should be under 200, about 200 milliamps I bet it will be at 120 volts. And this will be the primary, and this is the secondary that is going to go to the load. This is interesting. It's 3.25 or so, and you pull this up, and this is the inductance. And you can, so that's the effect of the steel laminate cores in there. And when it's ready to go, I put this bar back on there. So it's a three-phase AC transformer. This is a line reactor that has these removable bars. And you gotta make the surface really nice. Oops. Need to super glue those together. Anyways. So this goes across the top. This will be what you'd call a magnetic shunt bar. And when the back EMF happens, it's supposed to put itself into here, and the back EMF from the secondary happens, it puts itself into here. And if I understand correctly, since it's AC at every half cycle, the back EMF collides, and it's head-on collision. So now you have a elimination of the back EMF in this shunt bar. So you leave this blank, This is the primary, this is the secondary, and you put the load on this. And you should all watch Tim Tron's, Timtron, all one word, his latest live stream, where he has something like this. And the input was I can't remember the input. It was like 3.6 amps and 120 volts. And the output was 197 volts. And no, that was the, I don't know. You have to see the video, but it's 9 times over unity. There's the watts going in, the watts going out. Watts going in is from the grid, and very low draw, while the output is about 194 volts and 3.5 amps going out. Anyways, it comes to 9 times over unity. Just watch the video he did. Join his Patreon too, and help him out. So this is my attempt at something like he's doing. He has much bigger cores, and kind of knows what he's doing too. So now the theory is, I sprained my wrist playing soccer, took a fall. Wondering what this is about. So these 3-phase transformer cores, just the way they're made. Here's another one I got ready to go. I've put on hockey tape and a layer of epoxy over this, the cores here. And I have some smaller ones back there. So anyways, the way these work is the cores themselves, the design of it is 3-phase. It's supposed to be for 3-phase AC, so each phase here is 120 degrees out of phase than the one next to it. So 120, 120, 120 equals 360. So because they're out of phase, this is not going to really affect this. This is not going to affect this, and this is not going to affect this, because they're out of phase. So that has kind of how to explain how this works is, this is the primary. It's going to draw very little power, and when this one makes a lot of power into the load, when this, you need to have this into ferroresonance. So when the core goes into ferroresonance, now you get a lot of power out of here. And meanwhile, the back EMF, which usually screws everything up, it's going to kind of accumulate in this shunt bar over here from both of them. And because they're 120 degrees out of phase, it's kind of like the half cycle of each slams into each other in a head-on collision, and it eliminates the back EMF here. This is what I understand. It might not make sense, but that's kind of how I get the picture, how it works. So anyways, this is called a transverter. It's something that Hector's been preaching about for years. And there's other ways to do it. And but this is this way, with a very high impedance coil as the primary. So I guess that's almost about it. I'm working on this, trying to figure out these wires. I've made a few attempts, but I haven't got it figured out. You want the primary to be the highest impedance possible. Tim, in his video, he finds the 460 volt circuit, and then he runs the 120 volt in series or parallel, I'm not sure. So you want very high impedance here, and then about 4 times less in the secondary. Is what I saw with Tim's video. But here I'm doing quite extreme. I don't know if it's even going to work, but 669 ohms here, and then only 9.5 ohms here, so it's going to be interesting. So I guess that's about it. Okay, thanks for watching.
Okay guys, thank you for watching. Support Doug channel and enjoy your day. Have a nice day. See you later, alligator.